Welcome back, everyone. Our topic for today is about the area of sectors and segments of a circle. So, by definition, a sector is the area bounded by two radii and either their intercepted minor arc or the major arc. In this case, I am identifying this highlighted region as your sector. Another vocabulary that you need to know is a segment of a circle. Segment of a circle is that region that is bounded by the chord and the part of the sector of your circle. So right here, this pink highlighted area is your segment. It's called the segment of a circle. So let's go to the theorem right away. So the length S of an arc of a circle is in the same ratio to the circumference C of the circle as the arc measure M is to 360 degrees. So here we're talking of another topic right here, because here we are talking about area, and all of a sudden my first theorem talks about the arc length of your circle, or the length of an arc of your circle. So you're going to follow this formula. S represents the length of your arc. C is your circumference. M is the degree measure. And 360 is the overall degree measure of the circle. So it's the same as S is equal to M over 360 times 2 pi r. Or, to simplify things for you, S is equal to M over 360 times pi diameter. Theorem number 2. The area A of a sector of a circle is in the same ratio to the area of the circle as the measure M of the arc of the sector is to 360. So what does that mean? I want you to pay attention closely. The reason why I did not give an example yet on this one, I gave you right straight the next theorem, is because they're almost the same. So here, if you're looking for the length of an arc, you will have to go ahead and divide that by the circumference. So part of the arc over the circumference, but here area of what you're looking for over the area of a circle equals to M over 360. It's kind of the same. So now, if I'm just going to isolate the A, the one that I'm looking for, then you will have an M over 360 times pi r squared. Guys, I hope that you can find the pattern. All the same, here you're talking of length, which is why it's over the circumference. Here you're talking of area, which is why it's area of over the area of a circle. I would like first to acknowledge the author of the book that I am getting this example from. I'm getting this from the book of Mirna Kabansay. She is a Filipino author. And the example says, Chicago and Paris lie on a circle as shown on the figure right here. The radius is 4,000 miles. The measure of the arc from Chicago to Paris is 60 degrees. Find the distance between the two cities. So the distance is represented by S, and we use the formula, so on and so forth. The M is your 60 degrees. You simplify 60 over 360, which is 1/6. And then you do your 2 pi and you substitute your R. And now this part right here becomes 8,000 pi, which if you press on your calculator or if you calculate, the approximate distance is 4,189 miles. Okay, so once again, example number 2 is from the book of a Filipino author, Mirna Kabansay, and the problem goes: how much floor area must be allowed for this swivel chair? So the solution is going to come from our formula, which is looking for the area of a sector. and all you need to do is to plug in all the information. So this degree measure right here is 120 degrees over 360 times pi r squared, and your r is 1.5. Fix that on the calculator. It's gonna give you 2.25, and that is a 1/3. And then just press pi on your calculator, and it's gonna round to the second decimal place. And this is going to be the approximation that you are going to get. So for our last formula, how do you get the area of a segment of a circle? So as we said a while ago, this part right here that's shaded is called the segment. So we will use a little common sense and a little arithmetic here. For you to get the area of that region, you will have to get the total area of the sector first, and then get the area of that triangle right there and subtract them. And so that is it.